Hello everyone. Today we will be discussing on this question regarding data structures. So the question is, given the median of a running stream of integers, like we have been given a running stream of input data. We are supposed to calculate the median of that. For example, here I can take the given input as 2. Suppose if I take this array, now the median is calculated as 2. uh, Now the median would be 2. Suppose the input data is 2 comma 3. Now the median would be the average of the middle two elements. That would be 2 plus 3 divided by 2, which is equal to 3.5. So this is how we need to calculate. So first thing is, we will try to discuss this, how we will be solving this question, what would be our approach. And next thing is, we will discuss how effectively we can solve this question, like with a better time complexity. So the basic idea here is, we need to calculate the median for a given input stream of numbers. So we don't have any fixed array here. Like it would be simple if they would have given a fixed array. Then we would have done like sorting and we will be calculating the median. So we will think of how we can do this by using a better data structure. So here I'm just putting the pseudo code. So think that we have given a class, let this as running stream. Okay, here we have two things, like we will have a constructor for this class, and we have the function, which is used to add. We have other function which is used to get the median. So the thing is, every time we are getting the input data, we need to call this function, like which will add that input data to a declared data structure, and then we need to call this function to calculate the median. So the logic here is, so here we will be adding the number, and here we are calculating the median. So think that my given input data is 2, 6 and 9. We can say that the median will be 6, because if the size of an array is odd, then the middle element would be the median. In the other way, if the input array is 2 and 3, it would be the average of the middle two elements. Or if I have one added two more elements like 4 and 6, now the average would be the now the median would be the average of these 3 and 4. Suppose think that in the given input, the input data would be something like 9, 2 and 4. Then obviously the median would not be 2. So in order to get the median, first thing is we need to sort the given array and we need to find the median based on the size of the array. So here, after sorting this array, it would be 2, 4 and 9, and as the size of this array is 3, which is an odd, so it would be the middle element, that would be the 4. So this is our logic. Coming here, so here what we will be doing is we are sorting the array, sorting, we are doing sorting and calculating the median based on size. So if size is odd, middle element is the median. Size is even, then we are doing the average of the middle two elements in the sorted array. So this is our logic. So we can do it in couple of ways. So first thing is, like, here I can take a list which will take integer, and here I keep on adding the elements to that list, and here I can sort the array and I can find the median. So for sorting the array here, every time every time we are adding the new element to the list and we are doing sorting here. So if you think of time complexity for sorting an array, it would be n log n. So, and after sorting it, we can easily find the middle element. So it is a big O of one operation. And for every time we are sorting, our time complexity is n log n. So think that if there are 10 power 6 elements in the list, then our time complexity is 10 power 6 multiplied by n log n. So this the time complexity is very high for this. And anyhow, for adding the element for a list, it would be big O of 1. Like, we can add the element to the input list, like we can add at the end of the array. So it would be in an operation of big O of 1. And for calculating the for calculating the median, the first thing we need to do is we need to sort the array, and then we need to calculate the median. So for sorting, it would be taking n log n. So this is not an acceptable approach regarding the time complexity. So the logic here is we need to think of a logic where for calculating the median we just need big O of 1. So that is the, so we need to think of a data structure where we can calculate the median with just a big O of 1 time complexity, so that every time we are sorting, then we are reducing this n log n times of complexity for sorting the array. Yeah, for this we can do this by using priority queue data structure. So we will discuss how we can do this effectively by using priority queue. So we all know the basic functionality of the priority queue. So there is like a defined data structure, a priority queue. When we keep on adding the elements to the priority queue, it will automatically sort. There are two things. One is min priority queue and another one is max priority queue. So every time we add the element to the min priority queue, it will automatically take that element and it will sort based on the other elements. Like we internally it will be using heapify up or heapify down, uh, respectively, based on the priority queue which we are defining. So the main logic here is, so for any given input stream of data, what I will be doing here is I will be taking two priority queues. I will be dividing the input stream of data into two parts such that the left part will always contains the ele- elements in a sorted way, and the right part will contain the other half of the input stream of data. So if you think of the left part, here the topmost element, here we can say that this should be the maximum element, and coming to this right part, right half, we can consider this as the least element. So for having this as a top, that the top element should be the maximum value, so we can take this as a max priority queue, and I can take this as a min priority queue, so that this data structure always holds the maximum element on this part, and it will hold the minimum element in this right part. And also the thing is, so we can every time we can keep adding the elements to this priority queue. I will make sure that there in the left part there will be one extra element, or it should be equal. The sizes of those two priority queues will be equal. Think that the input stream of data, I am getting it as the input is 2. Now I am adding the 2 here in the left part, that is max priority queue. I am adding the 2 here. Now the difference, the and also I am making sure that the difference of the max priority queue and min priority queue is always 1. It will not be exceeding more than 1, so that if I have added the element 2, now the median will be, it just have only one element, so the median will be 2. Think that now I am getting one more element 5. So the question here is, I got an another input stream of data which is the element 5. The question here is where I need to add this element. Either there are two possibilities. One thing is I can add this element in this max priority queue, like the new input element 5, or I can add that new input element in the min priority queue. So think that, so what is the logic which I am making use of adding the new element is, I will always take the max priority queue element, the top element of the max priority queue, and I am comparing the input element with this value. Think that if the input element is greater than the max priority queue dot peak, which will return the max element, then I am putting that in the min priority queue. So here the input element is 5, and it is greater than max element of max priority queue, which is 2. So as it is satisfying the condition, I am putting that 5 here. Now the median of this is, I am just taking the top elements of the both priority queues and just doing the average of those two. So here if you compare, here the size of the max priority queue is 2, and the size of max priority queue is 1, and the size of min priority queue is 1. So both the sizes are equal. So it is an even, that so it will come like an even array, or the size is even. So I will be doing the average of these two, 5 plus 2 divided by 2, that would be my median. So now the thing is, suppose if I am getting the next input element as 7, where I need to add that input element. So there are two things. Either I can add in max priority queue or min priority queue, and keep that in mind. So if I am adding that in the min priority queue, then the size of the min priority queue is 2 and the size of the max priority queue is 1. And the condition which I am making making use of here is always the max priority queue size should be greater than the min priority queue, and it can be greater than 1. Like if the size of the min priority queue here is 1, and the allowable size of the max priority queue is 1 greater than the min priority queue size, that means it can be 1 or it can be 2, it should not be 3. Then we need to shift the elements, like we need to make sure that that balancing part is done. So think that now the new input element is 7. Now based on this condition, the input element is 7, and it is satisfying the condition the input element is greater than the max priority queue peak element, that is 2. So if it is satisfying this condition, now I am going to put this element in this min priority queue. Now the 7 will be here, and but now the size of this is 2, and size of this is max priority queue is 1. So it should not happen. So if the size is greater than 1, so that means the difference of the size should be equal to 1. Now what I will be doing is I am removing this top element in this min priority queue, and I am adding that element to this max priority queue, such that the new element would be, the new element here will be 7, and when I am adding 5 here, the 2 will come here and 5 will come here. Now the median will be, as the size is odd, the median is 5. So internally, every time when I'm adding the element to this data structure of priority queue, it will take care that it will automatically sort the things. So this is the logic where I am doing. And it should be the other way. Like if the size of the max priority queue is, if the difference is not equal to 1, suppose if the input data here I'm getting an input data of 1. Now we will check this condition. Now the input data is 1, and it is not greater than the max element. Now the max element of the max priority queue is 5. It is not greater than. So obviously I will be putting that 1 in this max priority queue. Okay. So now the max priority queues contain 1, 2, and 5, and the min priority queue contains 7. If you check the condition here, so the size of the max priority queue is 3, but the size of the min priority queue is 1. We need to make sure that the difference of the size should not be greater than, or it should not be greater than 1. It will be 1 or equal. It should not be greater than 1. So what I will be doing is I am taking this max element in this max priority queue and shifting that, and I am adding that element to this min priority queue. If I'm adding this to the min priority queue, the new element will be 5, and then the next element to that is 7. Like it will automatically take care of that sorting, that priority queue. And now what we will be having is 1 is shifted to here and 2 is here. Now the median will be, so here the 5 is here, 2 is here, and 1 is here. Now the median will be the average of 2 and 5. So this is how we will be calculating the median in a better time complexity using priority queue. So we will put, so we have visualized these things. Now we will try to put this logic here. So what I am doing here is I'm checking the size of the max priority queue. If max priority queue is empty, or we can put like size is equal to 0, adding the first element. I'm sorry, I need to put this logic in add. I'm adding the first element, max priority queue. Else, there are two things. I can put that we can put that incoming stream of element either in max pq or min pq. So think that I will be putting the new input stream of data into min pq if it is satisfying this condition. If the input number is greater than max pq, maximum element of the max priority queue, so I can get that maximum element by this function max pq dot peak. What I will be doing is, if it is satisfying the condition, I am putting that input stream of data or the input element into min priority queue. So min pq dot add, I'm adding that number here. Yeah. If min pq dot size, I'm checking here the condition that min pq dot size is greater than max pq dot size. What I will be doing here is, because every time I am adding the min pq new input element in the min pq, I want to make sure that the size should not be greater than 1. The difference of the size between these two priority queues should not be greater than 1. That simple thing, like I want to make sure that the max priority queue size should be greater than or greater than min priority queue, and it is allowed to be a one size greater than min priority queue, not more than that as well. So the new input element is added to the new input element is added to max priority queue. Now what I will be doing here is, I will be taking the max priority queue and adding the topmost element of the min priority queue. So here when I'm using this remove function, what it will do is it will return the element, it will return the minimum element and also removes the element from the queue. So after removing, I'm adding that element to the max priority queue. This is what happening. So, and the main condition is if the input element is greater than the max priority queue, I am doing this. If it is not, I will be adding the element to the max PQ. And also here I am checking the condition for checking the balancing. If max PQ dot size is greater than min PQ dot size plus 1, then here I am doing shifting. I am adding the element to this min PQ. I am adding that new element by removing the topmost element in the max PQ. So coming here, I'm just checking the condition. If max PQ dot size equal to min PQ dot size, I'm returning max PQ average of the top elements, max PQ dot peak less min PQ dot peak divided by 2. Else, we know that if the sizes are not equal, then the size of an input stream of data is odd, then we can say that the topmost element of the max priority queue is our answer. Yeah, this is how we can solve this problem in a better time complexity by making use of two priority queues. Like one is max priority queue and min priority queue, where they will hold all the elements in a sorted way such that the left part is sorted and the topmost element of the left part will be the maximum element, and coming to the right part, the first section or the first part of the right thing will be the minimum element, and the rest of the elements followed by this would be in a sorted way. That means if you take this 7 as the topmost element of this min priority queue, the all the elements in this part will be always less than 7. Sorry, it will be always greater than 7 because the top element is the minimum part. So that we can calculate the average of the middle two elements based on the sizes. This is how we can solve this problem. Thank you.